I am hoping that you had a chance to take a look at a couple of proofs, especially this one right here and this one right here, and maybe looked up a couple of others. Remember, we looked at this water example in class yesterday, and I also hope you went home and asked somebody if they remember this theorem from geometry or from math. A squared plus b squared equals c squared. Again, they probably remember it, but they may not remember what the parts of it are, and that's why it's much more useful to remember leg squared plus leg squared equals hypotenuse squared. So in part 2 of understanding and using the Pythagorean theorem, we're going to talk about how we can use this to kind of solve real life problems. Each one of these is going to have a missing side. Some of these are going to have diagrams that you do today, some won't. And we're probably going to do another section like this later on in the unit. But this is the value of the Pythagorean theorem. So you'll notice in this problem, just a quick two-line setup here. It says Jacob has a 20-foot ladder that is leaning against a house. The foot of the ladder is 7 feet from the base of the wall. Jacob would like to know how high up the wall the top of the ladder reaches. So if you ever run into a problem like this, draw a picture if you can draw one. So here's what we've got. We've got the land right here, so we've got the ground, and then we've got his house. So his house might look something like this. And he's got a 20-foot ladder that's leaning up against his house. So the ladder might look something like this, okay? And it says the ladder is 20 feet. So we're going to write 20 feet right here. We're going to label this. Now, if Jacob's house is like most houses, this is a right angle. So without saying it, they just gave us the hypotenuse of this right triangle. All right, and then it says the foot of the ladder is 7 feet from the base of the wall. So here's the base of the house right here. What they told us is this is 7 feet. So what we're missing is we're missing a leg. So I'm going to use X for this. And it says Jacob would like to know how high up the wall of the ladder reaches. And again, you can see that this right here, this distance would be how high up the wall it reaches. So we're going to use the Pythagorean theorem. Again, we're going to do leg squared plus leg squared equals hypotenuse squared. So this is going to be x squared plus 49 equals, let's see, what was 20 squared again? Again, 2 squared would be 4, followed by 2 zeros, so 400. We're going to subtract the 49, so we're going to get x squared equals, this is going to be 351. Now here's the cool thing about this. This is a story problem, so we get to choose the best way to do this. When we take the square root of both sides, we don't have to simplify this. All we have to do is throw this into a calculator. So we're going to say x equals, we'll grab the calculator, and we'll type in the square root of 351. So we'll hit second squared, that brings up the square root, 351, and then we're going to hop outside. Now, before we hit enter on this, I'd like you to take a look at this and maybe make a little bit of a prediction. If this is a 20-foot tall ladder and this is 7 feet away from the base, take a guess at whether this is going to be bigger than 20 feet or smaller than 20 feet. If it's going to be bigger, a lot bigger, smaller, a lot smaller, what's it going to be? Well, let's take a look at this and go ahead and have this calculated. 18.73. That might be a little bit surprising. By taking this, so if this ladder were straight up and down, it would be 20 feet up. By sliding this base out here 7 feet, it only lowers it a little bit more than a foot, 18.74. So let's round to the hundredths place. So this is going to be 18.73 feet. So whoops, and I'll change colors here. So 18.73 feet. Now if you wanted to change that into feet and inches, that would be fine. And let's just add a little more information. Let's see, up the wall. Okay, so this is 18.73 feet up the wall. So it reaches pretty far up there. Okay, let's take a look at this next situation. We've got Jenny, and here's Jenny's situation. She sees a ladder that reaches 20 feet up a wall. The ladder is 7 feet from the base of the wall. Jenny would like to know how long the ladder is. So this is the same type of situation, except for this time we've got different measurements. This is 20 feet. It reaches 20 feet up the wall. This is 7 feet. So you'll notice that what we're missing here is we're missing the hypotenuse. So we're going to do 20 squared plus 7 squared equals x squared. Leg squared plus leg squared equals hypotenuse squared. This is going to be 400. This is going to be 49. And this is x squared. So this is 449 equals x squared. And then we're going to take the square root of both sides. So again, the key is getting this set up, and then we hopefully are on autopilot as we solve these. These are just basic quadratic equations that we solve. So we're going to take the square root of both sides. So we're going to get x equals, and let's type that in here. So this is going to be the square root of 449, And again, take a guess at what this is going to be. A little more than 20, a little less than 20. What's going to happen here? It actually ends up being 21.1, let's see, 189. So if we go to the nearest hundredth, that's going to be 21.119. So 21.19 foot. That's the ladder. So we'll just write ladder right here, and we'll be all set and done with that problem. So notice that this had the same numbers in it. All we did was flip-flop. Instead of the ladder being 20 feet, it was 20 feet up on the wall, and that makes the ladder a little bit longer. Again, you're always going to run into Pythagorean problems, and the hypotenuse is always going to be the longest side because it's across from the biggest angle. All right, now Jenny and Jacob are at one corner of a rectangular field that is 100 meters by 300 meters. So we could stop right there. We could just draw a picture. Okay, so that we've got this rectangular field. It's 100 meters by 300 meters. And it says they need to get to the opposite corner of the field. So let's say that they are right here and they need to end up right here. So they want to start here, and end here. All right, so we'll start right here and end up there. Okay, it says they have two choices: go around the outside of the field or cut across diagonally. So they could go like that. All right, which is the shortest and how much shorter it is than the other option? Well, clearly it's going to be shorter if they cut across, but what we want to know is how much shorter is it. So for the first choice, so if they go outside, they'd have to go 100 meters and then 300 meters, or they could go 300 and then 100. Either way, it's going to be 400 meters. Okay, if they do a shortcut, whoops, and let's just write diagonally, diagonal, then we end up with this. We need to know what this guy is right here. So I'm going to use an S for shortcut. So this would be a leg squared plus a leg squared equals the hypotenuse squared. So this is going to be, gosh, let's think about what this would be. That's going to be a 1. Think about how many zeros we'd have. I think we have 4 zeros. And that's going to be a 9. And I think we're going to have 4 zeros. Now, I would not just rely on that. So let's just double check on the calculator. Let's do 100, and we'll square that. 10,000, so we're in good shape there. Let's do 300. And we'll square that. 90,000, so we're in good shape there. So these add up to 100,000 altogether. All right, and that equals s squared. So we're going to take the square root of both sides right here. So here's our shortcut. Is it going to be a lot shorter than 400 meters or just a little bit shorter? So let's check and see. We're going to do the square root of, and let's make sure we have the right number of zeros here. Got 5 of them. Double check here, because if you type this in the calculator wrong, it's going to give you the wrong answer. 316. So 316 point, let's go to the hundredths place. So 0.227, so that 7 is going to bump that last 2 up to a 3. So 0.23 meters. Okay, so there's our shortcut. Okay, which is shortest, and how much shorter is it than the other option? Okay, so diagonal is only 316.23 meters. Okay, so then we'd do 400 minus the 316.23, and let's see what we get there. 400, and I'm going to do something here. Notice above the negative it says ANS. I'm going to hit second. Whoops. I'm going to not do that. I'm going to do subtract that answer. So what that does is it allows me to pull this up, and just instead of typing that whole thing in, it'll just recall that. So it says it saved us 83.77. Now, just to show you that that gives us the same answer if we round it, we're going to subtract 316.23. So we'll hit enter. There's the 83.7. Okay, saves 83.77 meters. Okay. All right, now on today's assignment you're going to see some things like this with descriptions, some things with diagrams, but I can almost guarantee you there's going to be a problem like this on the unit test, and these are classic geometry problems, and you'll probably see them on the end of the year test. All right, good luck.